Hi everybody, welcome to this new Pix4D webinar. My name is Oliver Kung, I'm one of the co-founders of Pix4D. Very happy to host today's webinar, and the topic of today is going to be focusing on the mesh feature of Pix4D Mapper. So here are all the topics we're going to address today. So I'll give a quick overview, and then we'll go over each of these topics, showing quite many tips, improvements, knowledge about the mesh, as well as some really nice examples that we have. As usual, this webinar is recorded, so it will be available at the end of, it will be available in a few days as we will post it on our YouTube channel. As you're watching live the webinar, feel free to ask questions on the chat box on the bottom, and I'll pick them if they come during the webinar. We'll have anyway a small Q&A at the end of the session. All right, so let's get started, and let's have a quick glance first at the program for today. So the mesh. So first I'm going to introduce how is the mesh generated in Pix4D Mapper, what are the different options to generate, and I will also detail a little bit more what are the algorithms which are used behind to produce such a mesh. Then I'll compare the mesh versus the DSM versus the point cloud to give a bit of tips when should you use what and what's the accuracy of each of them. I'll discuss also of the different formats that the Pix4D Mapper is producing, so the OBJ, PLY, when to use which one for which different purpose. We'll also discuss about always kind of how many triangles should you aim for, and also for the texture. So what's the difference, what's more important, and what's the trade-off you need to do. I'll also quickly address how to perform really high detailed on large areas, how to modify, improve the mesh, and finally how to share and display them. But first, I think the most important is to start displaying some mesh. So, all right. This is a project that we did with our partner Waldo Air, who produce a small a pod that you can attach into airplanes. So this was flown with an airplane at very low altitude with a pod that integrates cameras, and this flight was done by our partner from Waldo Air. This city, I think, is Nashville, if I remember correctly. And what you see there on your screen is the 3D mesh of this city. And indeed, it does look very, very impressive. Even when we zoom in and we look at the detail, it does look very, very good. So let me first tell you how this mesh was produced. So let's go in the options of the software. You can see that the mesh was actually produced during step 2 of the processing. And you can see as it's in green that the step 2 has been processed. If we go in the options, you have to go in the point cloud and mesh, and there you can see generate 3D texture mesh is enabled. The target numbers in that case was 10 million triangles, and the texture size was set at 16,000 times 16,000. The format was, you can choose multiple formats to export it at the same time. So in that case, it was a PLY and a zipped OBJ that were created. So if I had to redo the mesh right now, I wouldn't restart the whole second part of the processing because it will generate the point cloud and then the 3D mesh. So what I would do is I would go in process, and there you can just generate 3D texture mesh. Will not redo the point cloud, but it will just perform the 3D texture mesh after the point cloud has been generated. A few more tips inside of Pix4D Mapper. One of them is in the visualization. So to enable point cloud, this you have to go in the tree, and this is where you can disable the visualization of the mesh, triangle mesh. And if you look here, you have also a button called Display Properties. If you open it, you have a few options on how to display the mesh. By default, you will see the textured the textured version. But you can also select monochrome, which is basically the mesh without the texture, just some shadow. And some very interesting one is you can also choose altitude. Altitude will color the 3D mesh with the different colors depending on the altitude basically on the altitude. So you can see red is higher than blue lower. For datasets which are a bit more topological datasets, we also added this other rendering of altitude, which goes from something like greenish to brown, which represents more like the mountains. For a city, it doesn't make much sense, but if it was done on a mountain, it would look really good. So let's go back to the texture mesh that we can see here. Okay, that was a nice dataset. Let's go into a little bit of understanding how this mesh was obtained. So as I previously said, to generate a mesh, you first need to perform the initial step, which is the calibration, and then you need to generate the dense point of cloud. And from that dense point of cloud, a mesh will be generated. How does it depend on the dense point of cloud? It will work if you have low number of points and high number of points. The difference is not that big. So you can save a lot of time if you want to quickly have a mesh for 3D visualization. You don't need to select the highest settings for doing the dense point cloud. You will have already very good looking results, even if you do a very fast dense point generation. So you may, if you're really interested in just having a visualization very fast, you may want to go actually in quite low settings of dense point to make it faster. Now, having said that, how does the mesh work internally? So the way the algorithm performs is that we take the whole scene and we divide it in many little cubes. Then these little cubes, we basically have a surface that we have some algorithm to pass a surface through all these little cubes, and then all these little cubes will transform into triangles. However, when we have little amount of information, meaning not a lot of 3D points, we will make much larger triangles. And so we will simplify already at the initial mesh. And when we have a lot of information, very likely we'll do a lot of little triangles. So after the initial mesh, the first thing we do, usually after the initial mesh, you get, depending on the project and the number of key point of densified points, you get between 100,000 and 10 million triangles. And this initial mesh, it can be 10 million triangles is very heavy to display. So we usually never display and never produce the 10 million one. So it gets produced internally in memory, but we don't display it. What we first do is we do a simplification step. And after the simplification step, we basically have the same type of mesh, but with less number of triangles. And basically, if you go in the software and you look at the options here, the maximum number of triangles is the setting of the simplification. So it's going to modify the initial mesh that got computed to a simplified version, and this is the one that will be displayed on the screen. Oops. Once this simplified mesh is constructed, what we will do is we will segment it. By segmenting, we basically mean we're going to try to find areas which are pretty flat, which are pretty uniform. And these areas, we will basically almost cut them. And once we have cut them, we will place them, all these flat areas, on a texture, on a image, and then we will use the original images to color them. To give a bit of meaning to what I'm saying right now, for example, let me find the data sets. Mesh. let's look at the picture of the city I just did before. So this is the texture that was generated. So if you zoom in, you can see there are many places which kind of look uniform next to one to each other. And this is exactly what I just said now. So if you look at the software, it will take the 3D mesh. It will find that, for example, this surface is very flat. So it will cut around the edges of this surface, and then it's going to create on the texture an area, and this area it's going to paint it using the images of the texture of the camera. And this is what we usually call a texture atlas. And there you can see this is a texture atlas generated from this project. And the software knows the 3D format of the file knows how to transfer this patch into the 3D texture. So these are the steps basically. So you need to first calibrate the project, produce the dense points, and once the dense points are done, you can then create the mesh. And inside of the mesh, you have first it's going to make tons of little triangles, and because it's too many triangles to be useful, it's going to have a first simplification step. And this is the amount of simplification. This is the option which is given to you in the option of the 3D texture mesh about the number of triangles. I'm going to a bit later in the talk, I'm going to talk more in details which are reasonable numbers to give there and what's the reason behind. Once this is done, after the mesh is simplified, the mesh is going to get segmented, and each of the segments are going to be textured, and then you see the results of the 3D mesh with the texture. Okay, so a 3D mesh is one of the output of the software, and the two other outputs which are relevant in terms of 3D basically is the DSM and the point cloud. All right, so about the DSM, let's a bit compare for different usage why one is more useful than the others and in which you should perform things. So maybe I'll just give the short summary first. The mesh is very good for visualizing because it's very attractive, it looks good, it's very visually impressive, but it's really not recommended for doing any computation or any measurement in it. It's really a visualization tool. The DSM is perfect, is not very good to visualize because usually it doesn't look that good. You don't see the facade of the building. That's when you have the 2.5D DSM, you don't see really the facade of the building. You only see the top. So it doesn't look as good, but to perform computation such as slope analysis or contour lines, it's much more efficient and also more precise. And finally, the point cloud from which the mesh and the DSM are computed. This is the type of 3D representation that you really want to use when you want to do precise measurements. The main reason is that the 3D point clouds gives you a very high sense of accuracy through density. I'm going to show it right now with this project. So there we just said that this is the 3D mesh. So now let's look at the 3D point cloud. Okay, so this is the point cloud. It doesn't look exactly as good as the mesh, and the main reason for it is the texture. The texture is not as high resolution as the 3D mesh, and perceptually for us humans, it makes it look a bit not as good, because we are much more sensitive to texture than actually geometrical information. However, when you want to measure, it's the opposite. Geometrical information is much more important than visual appearance. So this is something to remember. Let's find, for example, the top of this tower. Here in the point cloud, you can clearly see exactly the top of the point there. Whoops. Now let's look how the mesh looks like here. You can see that the little detail of the top of the tower was not saved in the mesh, because for mesh it's extremely hard to save very thin details. So if you had to measure the top of this building, the exact top, you would definitely better be off using the point cloud than using the 3D mesh. This is just one of the example. Another way to say is, let's look at the point clouds in some other areas, which might be, for example, empty. Okay, for example, in that side, we don't have the side of the building here. And in the mesh, in the 3D point cloud, you clearly see that you have less and less points, and here you don't have any points. So this gives you an indication that the software was not able to reconstruct the information there. It doesn't tell you that it's a hole, it doesn't tell you it's empty, but it just does tell you that there's not enough visual information to compute anything here. However, when you look at the mesh, you see that all the holes have been filled. But it's not because the hole has been filled that the information is correct. In that case, it looks like visually it makes sense. But if there would have been a balcony here, the mesh would not have been able to capture this information. And then if you rely on this measurement for high precision, you may end up with bad surprises. So that's another good reason not to use the 3D mesh as a tool for doing measurements, but really more as a visualization tool, something that helps you to make sense, something that helps you to guide a little bit, and to have something also very visually pleasing. By the way, and that's another nice feature of Pix4D Mapper, if you wanted to have even more accuracy than the mesh or the point cloud, and you really wanted to get exact the top of this there, you can really use this unique feature of the ray cloud, which basically allows you to visualize in the original images by clicking on a point. By clicking on this point, I have the real picture of the top of this tower, and I can do feature extraction by basically creating a new point, exactly clicking in the middle in multiple images, and doing that, I can exactly find the location of the exact top of the tower. So if you want to go for even higher precision than the point cloud and the mesh, then feature extraction using the ray cloud is kind of the ultimate way to extract very accurate information. And so this summarizes a little bit what I've just said now. The point cloud, so if we just think now about accuracy, the point cloud is really the best thing you would want to take because it doesn't have any interpolation. By interpolation, we are not trying to fill the holes. We only give a point when we are really sure that this is the position of this point. And when you have no points, then we are not trying to fill the gap. That's why I said no interpolation there. And you know that maybe that's an area where you shouldn't trust too much the results. So it's really about the fact that you can easily assess the quality. Now about the DSM. The DSM has a bit of interpolation because we do triangulation of the points for projects. However, the interpolation there is not very destructive. So we are not really changing the shape of anything. It's just filling the holes, so to say. So the accuracy is still as high, but what you lose because of the interpolation, it's a bit harder to assess accuracy. So if you had plenty of points everywhere, no problem. But in the case where you have areas which have a bit less of number of points, then you will see the interpolated results, and it's harder to actually say if it's true accuracy or if it's just interpolation. And then finally, the mesh has both interpolation and simplification, which means that the interpolation is going to make it hard to assess the quality in terms of accuracy, geometrical accuracy. And because of the simplification, you also will have a lower accuracy. So again, I think the point was made clear enough that mesh is really about visualizing results and shouldn't be used too much for doing distance evaluation. All right, so here are the different formats that Pix4D Mapper outputs by default, is able to output right now. So the most common one, I think the one that every 3D software in the world is basically has to support is the very, very old OBJ format. I think it's a format that was made in the 1980s. So it's a very, very old primitive format. But the good side on it is that more or less everybody is able to read it. So this is one of the formats we output. We also make a zipped version of it because the OBJ by default doesn't contain a texture. So it's going to generate the OBJ, and next to it, you will see a bunch of little files, and one of them is a JPEG that contains the texture content. So it's a bit of a mess. Instead of having one file, you have multiple files. And if you need to transmit it to somebody, you basically need to give all the files for him to see the texture. And that's why we also have a zipped OBJ, which is basically we take the OBJ and the texture and we zip them together. And this is pretty useful for when you need, for example, to send it to a web viewer, such as Sketchfab. One format that we added in the 2.0 version is this FBX format. This is a proprietary format made by AutoCAD, by Autodesk, and so it's compatible with most of the AutoCAD family type of products, including their competitors such as Rhino. The PLY is kind of a very, very old format, and actually it's even simpler format than OBJ. So you have also plenty of software that are able to read this type of formats. And finally, we also have a PDF. And we use some new features of Adobe PDF, which is about 3D viewing inside of PDF. As an example to that, there I just created, so this is Adobe Adobe Reader, and this is basically the 3D mesh of the guided tour, which comes with Pix4D Mapper as a 3D mesh. This is perfectly useful when you need to send it to a client or to somebody when you need to share the data set and you're not sure if this person has a 3D viewer. By sending the PDF, you basically are almost sure that if he has Adobe Reader, then he's able to visualize it. And included of Adobe Visualizer, you also have some tools which are letting you doing some basic measurements of distances, angles, and areas. Okay, so this is now, I talked about the two different, so these are the options that you can see in Pix4D Mapper when you look at the different set of options. So in terms of the outputs here, so I just been describing the different outputs that you can generate. Now the big question that I already raised a bit before, what should be you put as number of triangles and as texture size? So you can see that the different choice go from 256 to 16,000. And in that case, in number of triangle, you can go from a very low number, I think maybe as low as 1,000, and you can go up to 10 million. All right, so to answer this question, because it's not an easy answer, I've prepared two pictures on the right of this slide. The first picture, so they definitely, if you look at it with a high enough resolution screen and hopefully that the video is good enough, then you should be able to see that there's a huge difference in quality in the two different screenshots that I just took. However, and this is a very nice lesson about number of triangles versus texture. In the first picture, I generated the project with 1,000 triangles and a texture of 8,000 by 8,000. In the second example, I generated 10 million triangles and a texture size of 256 times 256. And you can see that from a visual point of view, it's not the amount of triangles. So the picture on below has 1,000 times more triangle than the picture on the top, but it really looks horrible. And by that, I really mean that most of the quality of triangle meshes is derived from texture. Texture is extremely important, much more than number of triangles from a good looking point of view. So the number of triangles is much less important than the quality of the texture. I'm not saying it's not important. You should not try to go for too low number of triangles. But if in case of to choose the texture, putting a higher texture usually provides much more impact than setting a high number of triangles. Now, what is good enough? What's enough triangles? For most of the projects, so up to, let's say, a few thousand of images, from 100 to 1 million number of triangle will look good enough for most of the projects. And you don't need to go higher because you won't notice the difference by increasing the triangles. Now, why limit the number of triangles? When one of them, there are many reasons for that. One of it is that by increasing the number of triangles, you will increase the file size. And nobody wants big files. And that's one thing, but most important than that, there's very little amount of software which are able to handle more than 1 million of triangle. So if you open most of 3D software, so let's say AutoCAD. AutoCAD is a very good example. If you give him more than 100,000 of triangles, AutoCAD is going to be very slow at trying to loading them. And when you try to manipulate the mesh, it's going to be also very painful experience. So whenever you do a project where the goal is to export it to AutoCAD, then I would even limit it to 100,000 triangles and not trying to go over that. And 1 million, so 10 times more triangle for most of the project will not give you a significant improvement in terms of visual quality. The texture, however, is much more important. And by default, the values is at 8,000 by 8,000. And the reason we did that is that this texture resolution is the one which is supported by most computers. For some laptops which have kind of weak graphic cards, and depending on the software you use to display them, 8,000 by 8,000 is already too high, and the software will not be able to load and display the texture. So this explains why we don't put higher texture by default in the project. And 8,000 by 8,000 kind of looks good enough for most of the projects. So you may want to put it higher, but then you also need to know that depending on your system, on your graphic card memory, and on the software that you use to render this 3D mesh, you may not be able to see the texture because it's too large, too big for the project to handle. So, as a short summary of this slide, the default values that we've put in the software is 1 million for the triangle and 8,000 for the texture. If your goal is to go more like displaying in AutoCAD, then you can and you should definitely try to reduce to 1,000 and maybe even the texture reduce it to 4,000 by 4,000. If you want to export to web viewers such as Sketchfab, then again, it sounds more it sounds better to also lower to 100,000 triangles and to go for a texture of 8,000 by 8,000. Now, if it's just to visualize it in the ray cloud, in Pix4D Mapper's ray cloud, then we did some effort to make it quite nice to display high number of triangles and texture. So 1 million and the texture by 8,000, 8,000 should work perfectly fine. Now there are some projects which are really, really big. Let's take, for example, this project. So it's only a little part of the city. It's not the whole city of Nashville. So if you had to do the whole city, for example, the type of algorithm that we are currently using in Pix4D Mapper is depending also on the size of the project. So we will not produce 100 million triangles if the project is huge. We will still limit it to something between 1 to 10 million of triangles. So which means that if you had a huge project, you will lose a lot of detail. So one way to do it right now in Pix4D Mapper, and if you have a very, very large project where you start seeing that you're really losing too many details in the triangle mesh, is to do manually splitting of your project and to generate per region a 3D mesh, and then to use a software to merge the different mesh together to have a very, very large high resolution mesh. To do so, basically, you would go in the processing area and you would create, for example, here an area. And then from this area, you will start the point cloud and the mesh. You'll have to recompute them. And this will compute a mesh and a point cloud just for this area. However, since you're taking a smaller area, you will have more detail. The mesh will be of higher detail. And repeat that a few times, and then you can start producing very, very high, huge meshes for larger areas. So I agree that it's not really the optimal way. It would be so much better if this was done automatically by the software, which is not right now at the moment, but that's definitely something at Pix4D where we are working to improve the algorithm to do all these steps automatically for you. So then you could do huge areas, a very, very high resolution mesh of huge areas. So right now there's a workaround by doing it kind of manually, but very soon we'll have the full workflow inside of Pix4D Mapper that will do the whole thing. Now another topic is about how to improve or modify the mesh. So let's take maybe this other example here. So this is the guided tour mesh, and you can see a few things there. So the mesh is not always perfect, and it really comes from the point cloud. And the mesh is generated from the point cloud. So we don't give tools to modify directly the mesh, but we give tools to modify the point cloud. So if you wanted, for example, let's take this tree. A tree will never look amazing in a 3D mesh. That's for sure. A tree is something that has so many little detail, and the mesh is never going to capture this type of little details nicely. So trees will never look good in 3D mesh. So maybe instead of having this kind of big blob, you'd rather want it to be totally flat. To do that, basically, okay, you have to go in the point cloud view. And in the point cloud view, you would select the points which are of the tree. So you do that doing this. And you will delete them. So here, there's a few more there. So let's continue deleting them. Okay, now that I have deleted these points, if I generate the mesh, the 3D textured mesh again, So for this small project, it should be pretty quick. You will see that you don't have a blob anymore. You basically have a flat surface. So this is a way to remove annoying blobs of the mesh. The way that the mesh algorithm work is if you have areas like here which have no points, no point clouds, it will try to fit a surface that kind of fits to the curvature of the side of the points. So as here you have points that go here on the top, it will make kind of try to follow the curve without really knowing which object it is. And that's why you end up with this, the mesh has been generated, you end up with kind of blob type of object. So now let's go back to the tree I removed. So here you can see that now this is the mesh in the area where I removed the tree. And so you don't have this weird, so let's remove the point clouds. You don't see the blob anymore, even though that you don't have any tree anymore. So that's one way you can do some editing to the mesh. And this is the editing that is included in Pix4D Mapper. Now, I also perfectly understand that this is not good enough. If you wanted to do other type of editing or editing directly the triangle mesh, then you would basically, if you want to do further editing, you would basically need to go through third-party point clouds to surface software. A bunch of examples which exist is VR Mesher and MeshLab. AutoCAD is also able to do that. So there's many software, and that's documented on our support website, that allow to also transform points to surfaces, to mesh. And they may provide more functionality in terms of changing triangles or changing options to transform points into triangles. Another thing which is also possible is to import the 3D mesh that we have in animation software such as Blender, Maya, 3D Studio Max. And when you import the mesh there, then you can, as an artist, modify anything, import real good-looking trees and things like that. So this is also possible to do further improvements. All right, so now finally about how to share and display the 3D mesh. I already talked a little bit about it. So for online sharing, so we are right now upgrading our mesh visualization tool on mapper.pix4d.com. So very soon you'll be able to use a really good viewer that we've been creating since a while on our website, and you can use that to share and to display your mesh on any browser. Another way to do it is we're working also very, very closely with this company called Sketchfab, which propose a service to also host and share 3D model. And the way to do it is you can easily go to Sketchfab and upload the zipped OBJ to their website, and then you can display it with passwords, with sharing options, and so on. Now, just something important, web viewing usually requires a low number of triangles, so maximum 1 million, but even better, 100,000. Doing web viewing of triangle meshes is already something heavy, and in addition, as it has to go through the browser, it's really not very good at handling really large meshes. So when the goal is to share these meshes online, try to go for smaller mesh as possible. On the desktop, well, I've shown that you can use Adobe Reader, that you can share the PDF. There's also, I don't know, for people who have upgraded to Windows 10, there is now included in Windows 10 OBJ viewer for 3D mesh. So you can import the OBJ in the 3D viewer of Windows 10, and you will directly be able to display it. If you want to try to display really massive number of triangles, one of the best software we've been seeing so far is something called Cloud Compare. It's an open source software. However, it's good at displaying triangles, but it's not good at displaying texture. So the texture will very often be downsampled, and so the texture will not look very good, even though you can load a huge number of mesh of triangles. And finally, all the software of animation and also CAD software, such as AutoCAD, 3D Studio, Rhino. There again, the number of triangles should be pretty limited if you don't want to have really sluggish and slow experience there. And the FBX format is probably the best format to choose. All right. With that, I'm going to conclude my this short webinar on mesh. If there is any question, please type them now, and I'll quickly answer them. All right. So one of the question: how can I visualize section profiles in the mesh or in the point cloud? We have currently in Pix4D Mapper, there is a very limited support to display profiles. One of the way to do it, but it's more of a workaround again than a nice way to do it, is to use in the option up top there, you have something called clipping box. So first you need to click edit clipping box. This will create a big box, and this clipping box can be basically moved, edited the size. And if you enable now clip point cloud, you basically can cut any point cloud to see the cross section of it. And one thing you can do it is also from the top. So here you can basically visualize also the profile from both the top and the side. However, you cannot then save, and you cannot do anything much more with that. So we are very well aware of that, and this been coming very often as a suggestions. So this is something for the next version. We are working hard into introducing a profile and cross-section tool. So for a better tool doing that, this is going to happen in probably Pix4D Mapper 2.1. For the time being, basically in Pix4D Mapper, you can do it like that. If you need more better cross profiling tool, some that we can suggest, that we do suggest on our website, is if you're working mostly in 2.5D, Global Mapper or Quantum GIS are good tools that provide a nice section and profile tool. And in terms of point cloud, well, the Bentley software called Point Tools is also a nice option to perform cross sections and so on. Okay, a question: how can I convert a point cloud to a ST model that I can print on a 3D printer? That's an interesting question. So STL is just a format, and there are tons of viewer, like for example MeshLab, which is a free viewer that could transform our OBJ into a STL format. In Windows 10, you can also import our OBJ, and Windows 10 has already a printing feature also for 3D printer. So in that respect, the format is not a problem. A bit more of an issue with the 3D models that are produced in Pix4D Mapper is the fact that we don't provide any depth of how do you say that? We don't do any boundaries. So the boundaries are of minimal width. We don't have any width in the boundaries. So basically, you need to use again there a more dedicated software that can transform our mesh into something with some thick boundary, and it depends on the material you are using in your 3D printer. So one way to do it that I would think is actually sounds like a good way to do it is create a very low resolution mesh in Pix4D Mapper, maybe something with 10,000 triangles. Open a software such as Blender, where you can open it, and there you can do you can adjust the size to make sure that you have quite some width on all the boundaries, such as it will not collapse when you print it. And then from there, from Blender, you can export it to your 3D printer. Okay, already now another question about is Pix4D Mapper mesh? So we have actually an edition of Pix4D Mapper that goes up to the mesh, but doesn't allow to do DSM in automosaic export. So the mesh version, the software Pix4D Mapper already works with any DJI or with any type of imagery. So you can already import any imagery in it, and the software will process them and produce mesh. So the software already is compatible. Probably what's the question was beneath is also we have an application, a phone application that allows you to better do grid flight for the drones of DJI. And this one, we have a beta version of the Inspire one working. You have to go in our forum, and in our forum, you'll be able to subscribe to the beta version that will allow you to control the Inspire one. However, it's not a requirement. You can also use the DJI app and control your drone manually to take pictures that will be then able to be used in Pix4D Mapper Mesh. Oblique imagery and anything works perfectly in Pix4D Mapper Mesh. All right, so thank you very, very much for attending this this webinar dedicated to Mesh. I hope that you've been able to learn quite a few tips and quite a few new things about Mesh, the utility, and how to use them and for what to use them. And well, thank you very, very much for attending this webinar. The next one will be in about 2-3 weeks, which will be question and answer. And then we'll have another one next month, which will be on a dedicated topic. All right, so thank you very much for attending this webinar. Hope you have a great day, and hope to see you very soon for the next one. Goodbye.